among our participants. So now I'm going to share my slides first. Is it visible?
Yes, it is visible. Yes.
Okay, I think I'm audible, right?
Yes.
Okay. Okay, now we're going to start the new topic on today's session, that is more on machine learning approaches, clustering algorithms. Okay, Professor Preeti just introduced me that I'm Gajendra Sharma, working in Kathmandu University, Nepal. Now I'm going to talk in this interesting topic. Okay, first of all, thank you very much for Asia Connect project providing me this opportunity, and special thanks to Professor Aparajita Oza and Professor Preeti. Okay, now let's start the session. So I think first of all, I'm going to deliver the lecture. Then if there are any questions, we may have some interactions at the end. So these are the contents of my lecture today. So first of all, some basic information about machine learning, different machine learning approaches or modern approaches on machine learning, more information about clustering algorithms, and finally, conclusion of my presentation. So these are the contents of today's session. So everyone knows that machine learning is one of the very important and emerging field of information technology. Okay, so it is basically a subfield of artificial intelligence, that is AI. It focuses on developing algorithms and models. So that means using machine learning techniques, we can develop new algorithms, and that these kind of algorithms may be applied for our research. And existing algorithms can also be used in machine learning research. So existing algorithms can also be used, and we can develop new algorithms, okay? So every month, more than around 100 new algorithms have been developed, according to a research report. So this is the recent data on machine learning algorithms. So it focuses on developing algorithms and models that enable computers to learn and make predictions or decisions without being explicitly programmed. Okay, so computer itself can't do anything unless we provide some instructions, some let's say information, or provide some input data. So that's why we have to instruct it properly so that it can function more appropriately. And machine learning provides that different methods that automatically learn from data. So no data, no processing. So we have data, algorithms, processing of data, and we can get new results. Furthermore, we can extract the underlying structure in the data to summarize information. Machine learning helps to accurately predict future data based on what we learn from current observation, that is generalization. And it typically needs a large collection of data or strong prior information. So if we have valid or primary data, we can process them to get new results so that our machine can work properly and efficiently. So this is the very brief introduction about machine learning. So I think you are familiar with this definition in your earlier sessions. So now you can see here a few quotes mentioned by the well-known, let's say, individual. A breakthrough in machine learning would be worth 10 Microsofts, according to Bill Gates, who is the chairman of Microsoft. That means machine learning is having very good future. And it may have a great challenge with, let's say, Microsoft. So that means Microsoft should develop or enhance themselves to, let's say, compete with machine learning technology. Machine learning is the next internet. So future of the internet is machine learning. That means AI and machine learning go together. And nowadays, AI has numerous applications. in different sectors, for example, in medical field, okay, in automation, smart city management, hydropower sectors, and so on. So AI and machine learning can go together. Machine learning is the hot new thing. So although the history of machine learning is not too old, but numerous researches are going on in this field today. So that's why it has a very good possibility in future to conduct several researches in this area. Moreover, I have 3 more quotations here. Web rankings today are mostly a matter of machine learning. Okay, so many web portals are developed. They are built under the concept of machine learning. So Prabhakar Raghavan, research director of Yahoo, machine learning is going to result in a real revolution. So CTO of Sun Electronics, machine learning is today's discontinuity. So sometimes I think machine learning may replace existing technology. Okay, for example, with the help of machine learning, internet may be more faster, more enhanced, with additional features, and with more, let's say, enhanced capacity. So it means machine learning is having a great future. So these are some important quotes that we have to consider. So then what is machine learning? I just mentioned you the basic definition. Automating automation, okay, so part of AI, getting computers to program themselves. If we have the skill of Python, it may help us to work with machine learning. Writing software is the bottleneck. Let the data do the work instead. So data is very important to work with the machine learning approaches. So always data is there that can be extracted from them using machines, okay, extracted from primary or original field that can be interpreted to get new results. So this is the basic definition. And I think in the previous sessions, you have studied about supervised and unsupervised learning, which are very important categories of ML, machine learning. I just revised them. So supervised learning, algorithms learn from labeled training data to make predictions or classify new or unseen data. The training data consists of input features and corresponding target labels or output, which the model learns to predict. And the objective is to learn a mapping between the input features and the output labels. For example, classification, where the goal is to predict a categorical label for a given input. Regression, where the goal is to predict a continuous output value. So by using supervised learning, we can develop a new model, okay, that can be used for our research and to develop a new project on machine learning. So similarly, we have unsupervised learning. So that means learning from training a model on unlabeled data. So supervised is labeled, unsupervised is unlabeled. And in this case, algorithms identify patterns or structures in the data without any specific target labels or outputs. And the goal of unsupervised learning is to find patterns and structure in the data without prior knowledge of the labels. The model learns to group similar data points together and discover underlying features in the data. For example, clustering, okay, and where the objective is to group similar data points together. So clustering means let's say select similar data and dissimilar data separately for further analysis. So clustering is one of the very important approaches of machine learning. Okay, then dimensionally reduction, where the goal is to reduce the number of input features while preserving the most important information. So this is the basic information about supervised and unsupervised machine learning. Then question may arises, then what is the exact difference between? Yes, please.
Sorry to interrupt. Are you changing your slides
No,
currently?
I'm just explaining. I'm not changing the slide. Okay,
Okay, it is that out.
just
Thank you.
explaining.
Okay,
Please do not worry. I'm not changing. So the
okay.
question may arise is, I'm just repeating the previous sessions briefly. So question may arise is, what may be the difference between supervised or unsupervised learning? And there are different components which may differ in these two categories. First one is labeled versus unlabeled data. So that means supervised learning uses labeled data, while unsupervised learning uses unlabeled data. So this is the first difference we have to consider. Second difference, predictive versus descriptive. So that means supervised learning is used for predictive modeling, where the goal is to predict a specific outcome. Unsupervised learning is used for descriptive modeling, where the goal is to find patterns and structure in the data. So this is the second difference. And the third difference is output versus no output. Okay. So that means supervised learning produces an output label or value, while unsupervised learning does not produce any output. So this is the another difference. And the fourth difference, training versus discovery. So that means supervised learning trains the model on labeled data, while unsupervised learning discovers patterns and structure in unlabeled data. So these are the major points which indicate the difference between supervised and unsupervised learning. I'll repeat again. First difference, labeled versus unlabeled data. Second, predictive versus descriptive. Third, output versus no output. And fourth, training versus discarding. So these are the basic differences. Now let's move further. I will change the slide now. So this figure shows the difference between traditional programming and machine learning. In traditional programming, you can see that data and program is input, computer is a processor, and output may be some result. Okay. In machine learning, data and output is the input, computer is the processing machine, and program itself is the output. So that means machine learning provides us some new programming techniques, some new algorithms that may be used to make a new model, new approach, new framework for conducting some research and for doing some decisions in IT field. So this is the basic difference between traditional programming and machine learning. Now this figure shows the basic information about machine learning. You can see if we talk about machine learning, then the most important keywords are algorithms, okay, data. So you means you are the programmer, you are the expert of this machine learning, or you may be the scholar of machine learning field, and programs. So algorithms, data, programmer, programs are keywords of machine learning. If you take the example of a garden, seeds are the algorithms, okay? So which are the basic foundation and helps to develop the entire model or entire system. Nutrients are the data. So data can be produced from the seeds, okay? So you are the gardener who look after the entire system or entire procedure, and plants are the programs. So programs helps to execute the entire system or operations. So machine learning approach can be compared with a gardening system. So this is simply an example. So the next question may arise, when do we use machine learning? So these are some answers of this question. First answer, human expertise doesn't exist. For example, navigating on Mars, okay? So because human brain has limited capability. To explore more information, we have to use AI technique or machine learning tools to navigate, let's say, path in Mars and in other systems, okay, other locations. Second answer, humans can't explain their expertise, speech recognition. So nowadays, many researches are being conducted on this speech recognition, which is sometimes very helpful to find the culprits, okay? If some bad incident is going on, then we can record the speech, recognize them, and find the culprits. So this is the second approach that may be used in machine learning. And third answer of this question, models must be customized or personalized medicine. And fourth answer, models are based on huge amounts of data. So if we have more data, then reliable the decision-making procedure. Example in genomics. So in different cases, we should use machine learning. So human expertise, where human expertise doesn't exist, where humans can't explain their expertise, or where models must be customized, and where models based on huge amounts of data. In such cases, we can use machine learning. So talking about machine learning, data is very important, I just told you. And those data should be clustered. Okay, they can be collected together for further processing and get new results. Then what is clustering? So this is another important question. Clustering and cluster analysis in machine learning. So basically a cluster is a collection of objects which are similar between them and are dissimilar to the objects belonging to other clusters. Okay, this is cluster. And another term we have clustering. And this is the process of organizing objects into groups whose members are similar in some way. Some are similar and some may be dissimilar, so that they can collect it in different locations for further analysis. And we have another term, cluster analysis. And cluster analysis is a set of methods or constructing a sensible and informative classification of an initially unclassified set of data using the variable values observed on each individual. Okay, this is cluster analysis. So now I'm not changing the slide. Okay, just revising some important issues here, talking about clustering. So now you are familiar with cluster. What is cluster? What is clustering? Similarly, you are familiar with cluster analysis. And clustering is one of the best known algorithms in machine learning domain. So which is the main theme of today's session, clustering technique in machine learning. So I'll repeat again. Clustering is one of the best known algorithms in machine learning domain, named as an unsupervised learning algorithm. The significance of clustering algorithm is to divide a large volume of data into smaller groups of data where there are no class labels available to process the data sets. So clustering is one of the very important approaches in machine learning. So I will talk you more about applications of clustering in coming slides. So now some applications of machine learning you can see in the slide here. For searching the web, computational biology, finance, e-commerce, space exploration, just navigate the path in Mars, okay? Robotics. So robotics is one of the outcome of AI. Information extractions using new algorithms. Social networks, for example, Facebook, MySpace, Twitter, YouTube, and virtual worlds we have nowadays, for example, Second Life. In these kind of social networks, we can use machine learning, debugging. So these are some major applications of machine learning. Now move further, you can see some important features here that automatic cars are having the use of machine learning approaches. Okay, they are controlled by some sensors or AI technology so that they can navigate their path, prevent themselves from collision. They can stop where needed and move further if necessary. So automatic cars are using the approaches of machine learning. So actually machine learning is one of the outcome of artificial intelligence. So this is the simple figure. So similarly, autonomous car sensors. So in this figure, we can see different, let's say, devices here. 360 three-dimensional ladder, GPS unit, stereo cameras. Okay, so camera helps to take the photos of different locations, find the path, navigation, and so on. So even machine learning can be used in automatic cars. So if you visit Japan, you can see automatic buses there, public buses, which run automatically and providing very good services. And even in the US, many transportation systems are automatic now. Even we have automatic aeroplane system. So these are one of the outcome of machine learning approaches. So similarly, autonomous car technology, laser terrain mapping, path planning. So automatic cars are one of the outcome of machine learning. I just mentioned this. Similarly, face image recognition. So a number of researches are going on in image recognition. Okay, input image in the input level, and when we process it in different levels, we can recognize the original faces. So pixels, edges, object parts, object models provides us the original face of some individual. So generally in automatic, let's say number plate of cars recognition, we can take this example. Similarly, learning of object parts. Okay, so for example, if you have taken the picture of some objects which is not visible or not clear, you can process them in different stages using different machine learning algorithms, and you can locate the exact description of that object. Okay, what is the object about? So what is the size? What is the basic features of that object? How it was extracted? So many information can be found. And even my students have done some research projects in master's level on machine learning, on face recognition, speech recognition, and image processing. And they have done very good research on it. And you can find my papers online as well in image recognition. And next approach is training on multiple objects. So for example, train on 4 classes, for example, cars, faces, motorbikes, airplanes. And in this case, second layer may be shared features and object-specific features. Third layer, more specific features. That means if we process them in different levels, then it's very easy to train the objects on multiple levels and identify them easily using different machine learning approaches. And this is a simple block diagram for machine learning for speech recognition. So in this figure, you can see 4 major units: feature extraction, neural network, which can use the principle of AI, decoder, transducer, and language model. So that means original language can be processed using neural network technology, and decoder, which is one of the important device for converting analog into digital and digital into analog signal. And that provides the exact result, okay, original speech, which may be helpful to identify the unknown voices of some individual. So ML, machine learning, is used to predict a phone state from sound spectrogram. So this is one of the major applications of machine learning in speech recognition. So now moving ahead, if we summarize machine learning, tens of thousands of machine learning algorithms are being developed nowadays every year, every time, okay? And hundreds new are added every year. So this is the recent data. And every machine learning algorithm has 3 components. First one is representation, second evaluation, and third optimization. So machine learning has a very good, let's say, future for conducting new research and innovate something new in this area. So then what is representation? So decision trees you have studied earlier. So this may be the example of representation. having sets of rules and programs, instances, graphical models, for example, Bayes and Markov nets, neural networks, support vector machines, model assemblers. So these are the representation components of machine learning, which helps to identify objects, process them, and get the end result. Then second approach, we have evaluation for accuracy of the data. To maintain accuracy and data accuracy, precision and recall technique, to minimize code error, to find out likelihood model, to test posterior probability, cost and utility of the system, margin, entropy, KL, divergence. So KL is one of the important clustering technique in machine learning. So for evaluation of entire system, we can use machine learning approach is an evaluation unit. And third one is optimization. And in optimization, we have three important components. First one is combinational optimization, for example, greedy search, or let's say greedy algorithm. Second one is convex optimization, gradient descent. Third one is constraint optimizing, linear programming. So greedy search or searching algorithm, for example, we have Prim's algorithm, we have Dijkstra's algorithm. In this case, we can also use machine learning approaches, convex optimization, linear programming model. So these are some examples of optimization component. Okay, now talking about different types, I've already talked about supervised and unsupervised learning. Just to tell them in short, supervised learning. So training, in this case, training data includes desired outputs. In unsupervised learning, training data doesn't include desired outputs. Semi-supervised learning, training data includes a few desired output. And we have reinforcement learning, rewards from sequence of actions. So reinforcement learning, I'm going to tell you in the coming slides. So which is another type of learning system. Similarly, we have nowadays active learning, okay, online learning. So these are also one of the outcome of machine learning approaches. Even in online learning, we have some important digital transforms which are built using machine learning techniques, AI techniques, for having multiple services. For example, sharing teaching materials, storing entire teaching contents, providing examinations, providing assessments, and so on. So entire learning systems are based on the foundation of machine learning. And we have inductive learning. So this is the simple example. So given example of function x, fx, two functions, predict function fx for new examples. So discrete function is classification and continuous function is regression. So classification and regression are important techniques of machine learning. And classification and regression are the outcome of clustering, okay? So if we have classification and regression, then it can be said that machine learning may have good clustering techniques or good clustering of data have been done. So function fx is equal to probability, and which is proportional to probability estimation. So inductive learning is another outcome of machine learning. So some more examples of supervised and unsupervised learning, you can see. Supervised learning, recent tree induction, rule induction, instant-based learning, Bayesian learning, neural networks, support vector machines, model ensembles, learning theory. And clustering theory is frequently used in unsupervised learning. And similarly, dimensionality reduction. So talking some more information about clustering, it has some wide applications. Without changing the slide, I will talk more about clustering here, major applications. First application of clustering may be data exploration and understanding. Okay, so that means clustering helps in understanding the underlying structure or patterns within data. By grouping similar data points together, clustering provides insights into the relationships, similarities, and differences among the data instances. So in this case, it aids in exploratory data analysis, identifying data characteristics, and gaining a deeper understanding of the dataset. So this is the first application of clustering. Data exploration and understanding, first application. And second application, customer segmentation and targeted marketing. Okay, segmentation is another keyword in clustering. Segmentation means grouping together. Okay. And targeted market. We have to segment the market to study demographic information of the consumers so that we can provide them new services or offering them new products. So in this case, clustering can be done. So clustering is widely used in marketing to segment customers based on their behavior, preferences, okay, or demographics. By clustering customers into distinct groups, businesses can better understand their target audience, tailor marketing strategies, personalize recommendations, and provide targeted advertisements or promotions. So this is the second application. That is customer segmentation and targeted marketing. And third application of clustering is anomaly detection. So in this case, clustering can help detect anomalies or outliers in data. And by identifying data points that patterns or behavior observed in the majority of the data, clustering algorithms can assist in detecting fraudulent transactions, okay, fraud transactions, network instructions, network intrusions, or unusual events in various domains, including finance, cybersecurity, and healthcare. So this is the third application. That is anomaly detection. And fourth application, image and object recognition. I just mentioned this application. So clustering is employed in computer vision tasks such as image and object recognition. So in this case, clustering techniques can assist in grouping similar images or objects together based on visual features, enabling tasks like image categorization, content-based image retrieval, and object detection. So this is the fourth application. And fifth application, document clustering and text mining. Okay, so this is another important application of clustering. And in this case, clustering is valuable in organizing and analyzing textual data. By clustering documents or text snippets based on their content, clustering algorithms aid in document categorization, topic modeling, sentiment analysis, and information retrieval tasks. So nowadays, sentiment analysis is very popular in research. Okay, you can use some regression techniques for data analysis. You can develop some new models using sentiment analysis, and even popular in marketing research. Sentiment analysis is one of the outcome of machine learning approach as well. And the next application, recommender system, which is even widely used these days. Clustering can be used in recommender system to group similar users or items based on their preferences or behavior. So recommender systems can be used in hotels, okay, restaurants, to check their variations in food services, accommodation services, and so on. So in this case, by clustering users with similar preferences, recommender system can provide personalized recommendations based on the preferences of users within the same cluster. And the next application of clustering is image and data compression. So in this case, clustering techniques such as vector quantization are employed in image and data compression. By representing data with a smaller set of representative clusters or centroids, Clustering allows for efficient storage and transmission of large volume of data. Okay, data compression is another important technique. So nowadays we have to use data online from one location to another. In this case, clustering technique can be used. And the next application and the final application of clustering may be dimensionality reduction. Okay, dimensionality reduction. So in this case, clustering can be utilized for dimensionality reduction, where high dimensional data is transformed into a lower dimensional representation. By clustering similar data points together, dimensionality reduction techniques can help in simplifying data analysis, visualization, and computational efficiency. So these are a few applications of clustering. Okay, I'll repeat again the major points here. So first application is data exploration and understanding. Second, customer segmentation and targeted marketing. Third, anomaly detection. Fourth, image and object recognition. Then document clustering and text mining, which is another application. Recommender system, image and data compression, and finally, dimensionality reduction. So these are common applications of clusterings, which are popularly used in machine learning. Now moving ahead in the slide. So these are some practical applications of machine learning. For example, understanding domain, prior knowledge and goals on, let's say, IT field, data integration, selection, cleaning, pre-processing, post-processing, and so on, developing learning models, interpreting results, consolidating and deploying discovered knowledge, and maintaining loop. So these are some practical approaches of machine learning. And I just mentioned that machine learning is one of the very important branch of AI, okay, artificial intelligence. So which is frequently used for pattern extraction, data fitting into functions, data classification, and so on. And we can learn and improve with historical data through machine learning, so that we can save our time and enhance application. And machine learning helps to bridge theoretical computer science and real noise data, or theoretical and practical applications can be merged together to get some new results. So these are some common machine learning practices which are being used nowadays. So talking more about supervised and unsupervised learning. So these are some pictorial representations. Unsupervised learning, there are not predefined and known set of outcomes, okay? And they look for hidden patterns and relations in the data. So this is a figure which shows unsupervised learning. So these data are not arranged well. They are, let's say, spread haphazardly, but we have to, let's say, manage them more efficiently for analysis. So unsupervised learning, this is the pictorial representation. And I just told you that supervised learning is guided by two important problems. One is classification and regression. Okay, so two approaches are very important to develop supervised learning. So classification predicts which class a given sample of data. Okay, we can define the class as you see in the figure. And regression predicts continuous values. You can see in the red marking here. So classification and regression are frequently repeating and important components to define supervised learning, which is widely used in machine learning. So machine learning is a complete process. You can see in this figure, it has some major objectives, okay? To meet those objectives, we have to collect some data, preparation of data, building model based upon those data, model evaluation, model development. So this is the continuous process. We can develop a new model, we can refine it, test it, and revise it. So this is a circle, okay? So machine learning is an entire procedure to make important decisions in automation. And there are different learning associations in machine learning or supervised and unsupervised learning. For example, basket analysis to a product to may have some predictions of two objects. Okay, for example, chips or beer. So basically, the interest of people is different. Generally, children prefer chips, and adult people prefer beer. So for comparing two items, we can use learning association technique to select some objects, okay, to make some decision. So in classification, simple example may be credit scoring in the exam and differentiating between low risk and high risk customers from their income and savings. So that means making some clustering of interest, for example, some income levels and saving rate, we can make some decisions. So classification is another important of supervised learning. So face recognition, I just told you, training examples of a person. These images are some outcome of the machine learning approaches. Regression is one of the important technique of approach of machine learning. If we have to, let's say, fix the price of a used car, or if we are going to buy a second-hand car, then we have to compare its model with other models. We have to predict its future output, okay, its previous, let's say, applications, and so on. So comparing with different models, we can make a decision whether to buy a second-hand car or not. In this case, regression techniques can be more useful. So now the second part of my today's talk is more approaches on machine learning. So first part is about machine learning, okay? So basic information and its major significance. The second part is more and advanced approaches on machine learning, which are being used nowadays. So these are some extended versions of machine learning. The first one is reinforcement learning. So generally, reinforcement learning involves an agent learning to interact with an environment and make some decisions to maximize a cumulative reward. And to get some feedback from other sources, we can use reinforcement learning. It has major applications in online game playing, okay, robotics, autonomous driving, and so on. So reinforcement learning is one of the major outcome of AI, okay, another implementation issue of AI. Similarly, transfer learning, second approach, it generally involves leveraging knowledge from one domain or task and applying it to another related domain or task. Now, in this case, instead of training a model from scratch, transfer learning allows the model to utilize pre-trained knowledge often obtained from large-scale datasets or tasks for designing, a speech recognition system, and for let's say designing many autonomous cars and transportation systems. We can use transfer learning to compare different knowledges and different results to make the new system. So unsupervised learning, I just told you, this is another approach. So it focuses, I just mentioned that it focuses on finding patterns or structure in unlabeled data, which is different than supervised learning. Clustering and dimensionality reduction are common techniques using unsupervised learning. And some popular examples may be exploratory data analysis or exploratory factor analysis. In this case, sentiment analysis can be used, anomaly detection, data processing, and so on. So this is unsupervised learning. And furthermore, it includes learning what normally happens without having any output. And in this case, clustering is the important technique for data collection. And some example of applications are customer segmentation in customer revenue management, image compression, or color quantitation, bioinformatics, or learning motives. So these are some general information about unsupervised learning approach. So similarly, we have generative adversarial networks, okay, which are another modern approach of machine learning. So adversarial networks usually consist of two neural networks. First one is a generator and the second one is discriminator, which compete against each other. And in this situation, the generator generates synthetic data samples, while the discriminator tries to distinguish between real and synthetic data. Examples may be image generations from different sources. Even generative adversarial networks can be used for traffic system, the traffic policies can use this system to, let's say, observe the exact situations or faults made by vehicle riders in the roads. They can use these techniques to find the fault. So image generation, data augmentation, and unsupervised representation learning. So this is another approach. Similarly, we have semi-supervised learning, which is different than supervised and unsupervised learning. This is a model which is trained on a combination of labeled and unlabeled data. Since labeled data is often expensive or time-consuming to obtain, semi-supervised learning can leverage the abundance of unbalanced data to improve performance. So semi-supervised learning can bridge supervised and unsupervised learning, okay, to make some important decisions. Active learning, so which is becoming more popular in universities nowadays to provide some new learning mechanism. Generally, active learning involves an iterative process where the model actively selects the most informative samples to be labeled by an expert. And the main objective of active learning is to reduce the labeling effort required to train a model while maintaining good performance. In this also, we can develop new we can use machine learning algorithms to provide the learning system more smarter and more effective, which can be directly used in university classrooms. So similarly, online learning, we all are familiar with online learning, okay, so nowadays. So this is also known as incremental or streaming learning. Streaming means online, happening now, or live incident, we can share. It involves training models and continuously arriving data in real time. So online learning became more popular during COVID-19, pandemic. It's because almost every universities had their classes online, assessments online, okay, learning materials online. So it was more popular nowadays. Even nowadays, many universities are adopting blended mode for teaching learning, so that if next pandemic comes, they are ready to cope this situation. So that means blended learning is becoming popular these days. And online learning adapts models incrementally, is new data, so which becomes available easily. This approach is useful when data arrives in a continuous stream. So I think most of us are familiar with online learning approach. So, uses of supervised learning, I just mentioned that for prediction of future cases, knowledge extraction from different sources, data compression, outlier detection. So these are major implementation uses of supervised learning. And reinforcement learning, I just mentioned briefly. So this is one of the very popular learning policy, which provides a sequence of outputs and alternatives for learning methods. It has no supervised output, but delayed reward system can be used, or it can provide some credit assignment system or problem used in game playing, robotics, multiple agents, and partial observability. So reinforcement learning is becoming more popular in machine learning research nowadays. So these are some new approaches on machine learning. We just mentioned you briefly: reinforcement learning, transfer learning, unsupervised learning, generative adversarial networks, semi-supervised learning, active learning, online. So all these approaches you can use in your master's or PhD thesis, okay, or even in your project. And these are some uses of supervised learning. And this is the brief information about reinforcement learning. So now the next part of today's lecture is clustering algorithm in machine learning. I just mentioned you some basic definitions about clustering, okay? So simply the clustering is the process of grouping a set of objects into classes of similar objects, which is very, let's say, significant for data analysis, okay? Using collecting high amount of data, compressing high amount of data can be more easier by clustering technique, which is one of the major outcome of machine learning. Now the question may arise, what may be the objectives of cluster analysis? So I'll talk some more information without changing the slides here. So what may be the objectives of cluster analysis? The answer may be finding groups of objects such that the objects in groups will be similar or related to one another and different from or unrelated the objects in other groups. So that is the major objectives of cluster analysis. For example, we may have some intra-cluster distances. We have inter-cluster distances, which can be matched together, which can be gathered together for analysis. So this is one of the basic example of clustering. Then the next question may be asked, so what is good clustering then? What is good clustering? And the answer is a good clustering method will produce high quality clusters with high intra-class similarity and lower inter-class similarity. So that means the quality of a clustering result depends on both the similarity measure used by the method and its implementation. And the quality of a clustering method is also measured by its ability to discover some or all of the hidden patterns. So to match intra-class and inter-class similarity, we can use clustering system. So by clustering, we can compress data easily, process them more efficiently, and get a good result. And the next issue may be measure the quality of clustering. So how to measure the good quality of clustering? And the answer may be first approach or first answer may be dissimilarity or similarity metric. So similarity is expressed in terms of a distance function, typically metric, okay? And there is a separate quality function that measures the goodness of a cluster. Goodness of a cluster is another feature. The definitions of distance functions are usually very different for interval scaled, Boolean, categorical, ordinal ratio, and vector variables. Weights should be associated with different variables based on applications and data semantics. And it is hard to define similar enough or good enough. The answer is typically highly subjective. So clustering should be of high quality. Okay, so this is the basic definition of clustering. So now I'm sending the slide now, a data set with clear cluster structure. So you can see in this figure, different clustering techniques are here. So how would you design an algorithm for finding the 3 clusters in this case? So 3 clusters in different locations. We can store data in 3 locations. We can process them, analyze them, and develop a new model. Okay, so for model development, clustering technique can be helpful. And some major applications of clustering is for navigation, for improving recall in search applications, for better navigation of search results, for speeding up vector space retrieval. So talking about some overview of different clustering approaches, I will talk more without changing slides here. So K-means algorithm is very popular now. We have different categories, for example, K-means, okay, hierarchical clustering, mean shift, density-based spatial clustering of applications with noise, Gaussian mixture models, spectral clustering, and so on. FET propagation, optics. So that means ordering points to a unified cluster structure. Agglomerative clustering. We have Birch, self-organizing maps, and so on. So K-means is frequently used clustering system. I'll talk some more information about K-means. So basically, K-means is a widely used clustering algorithm. It aims to partition data into a predefined number of clusters, where each data point belongs to the cluster with the nearest mean, that is called centroid. The algorithm iteratively updates the centroids until convergence is reached. So I will show in the next slide, what is K-means. Then similarly, we have hierarchical clustering. Hierarchical clustering builds a hierarchy of clusters or network of clusters by recursively merging or splitting them. It can be performed in an agglomerative or bottom-up or divisive top-down manner. The result is a tree-like structure, which is called a dendrogram, that shows the relationships between clusters. So dendrogram is very important keyword here. So which represents is a tree-like structure. Similarly, we have mean shift clustering. And mean shift is an iterative clustering algorithm that seeks models or high density regions in the data. It starts with random data points as initial centroids and shifts them towards the region of higher density until convergence. The final centroids represent the clusters. And the fourth category, density-based spatial clustering of applications with noise, or DBSCN. The abbreviation is DBSCN, density-based spatial clustering of applications with noise. So this is a density-based clustering algorithm. It groups together data points based on their density and separates regions of lower density. It doesn't require specifying the number of clusters in advance and can discover clusters of arbitrary space. So this cluster is robust to noise and can handle datasets with varying density. So this is the fourth category. And fifth category, Gaussian mixture models, or GMM. So GMM is a probabilistic model that assumes data points which are generated from a mixture of Gaussian distributions. So basically, Gaussian mixture models assigns probabilities to each data point belonging to each cluster and estimates the parameters using the expectation maximization algorithm. Okay, so this is the new algorithm, expectation maximization. And this algorithm, this clustering allows for soft assignment of data points to clusters. So this is about Gaussian mixture models. Similarly, we have spectral clustering. Okay, spectral clustering is another important clustering mechanism. And this clustering is a graph partitioning problem. It transforms the data into a graph representation and performs clustering based on the eigenvectors or spectral properties of the graph Laplacian matrix. Spectral clustering is effective for datasets with complex structures and can handle non-convex clusters. So this is the brief information about spectral clustering. So similarly, we have affinity propagation. So generally, affinity propagation identifies exemplar data points that best represent clusters. It uses a message passing mechanism between data points to determine exemplars and assigns other data points to their respective exemplars. The number of clusters is automatically determined based on the data. Okay, so this is about affinity propagation. Then we have next category, optics, and the full form is ordering points to identify cluster structure. Ordering points to identify cluster structure, optics. This is a density-based clustering algorithm that creates an ordering of data points based on their density and connectivity. It produces a reachability plot that represents the cluster structure in the data and allows flexible extraction of clusters at different density levels. Our next approach, we have agglomerative nesting. Agglomerative nesting. So this is so basically it uses a nested clustering structure to capture clusters at different levels of granularity. So this clustering techniques merges the most similar clusters until a single cluster is formed, resulting in a dendrogram representing the hierarchy. And the next approach we have BIRCH, and the full form is balanced iterative reducing and clustering using hierarchies. Okay, and this is a hierarchical clustering algorithm that uses a tree-based structure to represent clusters. So tree-based technique. Okay, it builds a tree structure from the data, compressing the information to maintain a compact representation of the clusters. And the last approach is self-organizing maps, SOM, the abbreviation. So this is also known as coordinate maps in an unsupervised neural network-based clustering technique. It maps high-dimensional data onto a lower dimensional grid where nearby grid units represent similar data points. And this clustering technique retains the topological relationships of the input data and can rebuild underlying structures. So I briefly talked about different clustering techniques, for example, k-means, hierarchical mean shift, density-based spatial clustering of applications noise, Gaussian mixed models, spectral clustering, affinity propagation, optics, agglomerative nesting, BIRCH, self-organized maps. So these are widely used in machine learning techniques. So now there are many issues for clustering. For example, clustering representation. Okay, so that means document representation, notion of similarity or distance, data location, and how many clusters you have to define. So these are some important issues in clustering. So size of the data, okay, how many number of clusters are important. And clustering algorithms are very important in machine learning approach. And generally we have flat algorithms, hierarchical algorithms, which are becoming more popular in clustering algorithms. So flat algorithms usually start with a random partitioning, which has, in this case, k-means clustering is widely used. And hierarchical algorithm can be used for bottom-up approach, okay, instead of top-down. So these are two popular clustering algorithms that we can use in our research. So similarly, we have hard versus soft clustering. Hard clustering, in this case, each document belongs to exactly one cluster. A soft clustering, a document can belong to more than one cluster. So this is the basic difference. So multiple clustering and soft clustering, so that we can compress the data more efficiently. And similarly, we have partitioning algorithms in clustering technique, which is called partitioning method. So in this case, we can construct a partition of n documents into a set of k clusters. So for example, there is a set of documents and the number of k. We have to find a partition of k clusters that optimizes the chosen partition criterion. And in this case, we can use k-means algorithm to find the solution. So k-means algorithm, I just told you. Select k random documents, S1, S2, S3. They are using as the seeds. And we have to find out the more clustering outputs here. So that means in this, by implementing k-means algorithm, we can define the number of clusters, okay, category of data, and size of the data. So k-means is a simple and most general clustering algorithms, which is mainly used to classify the given data set that is unlabeled, okay? So the example shows here. And this algorithm mainly aims to find similar clusters represented by variable k. For this purpose, this algorithm uses the mean or centroid as a metric to characterize the cluster. So different steps for clustering may be partition objects into k non-empty subsets, okay? Compute seed points is the centroids of the clusters of the current partition. Then assign each object to the cluster with the nearest seed point. Then go back to the second step and stop when no more new assignment. So 4 major steps we may have to analyze data using k-means algorithm. And it can also formulate a loop. Okay, for example, step 1, select key points in the data space and mark them as initial centroids. And we can formulate a loop. Step 2, maybe assign each point in the data space to the nearest centroid to form key clusters. Step 3, measure the distances of each point in the cluster from the centroid. Step 4, calculate the sum of square error to measure the quality of the clusters. Step 5, identify the new centroid of each cluster on the basis of distance between points. And step 6, repeat step 2 to 5 to define until centroids do not change. And this is the end of the loop. So in the different steps, we can define k-means algorithm. So here is another example: pick seeds, reassign clusters, compute centroids, reassign clusters, and convert. So different types of clusters can be merged together so that we can define them and we can set an appropriate algorithm to process those data. So convergence of k-means, it defines goodness measures of cluster. K is sum of square distance from cluster centroid. So this is the expression. And reassignment monotonically decreases z since each vector is assigned to the closest centroid. So k-means is popularly used nowadays, but it may have some strengths and weaknesses, okay? And some major strengths are simplicity and efficiency for implementation. This is the first strength. Second is easy interpretation, applicability to various data types, skills to large data sets. This is the another strength. Convergence guarantees, okay? Can warm start the positions of centroids, easily adapts to new examples, and it generalizes to clusters of different shapes and size. So these are some strengths of k-means. And it has some weaknesses as well. For example, sensitivity to initialization. It needs to specify the number of clusters, okay? So number of clusters should be fixed. Outlier sensitivity, bias towards equal size clusters, inability to handle non-numeric data and missing values. So k-means has both strengths as well as weaknesses. And we have a few variations, issues in k-means, and a few variants of the k-means which differ in selection of the initial k-means, okay? dissimilarity calculations, strategies to calculate cluster means. So we can handle different categories of data using different approaches. For example, replacing mean subclusters with modes, okay? Using new dissimilarity measures to deal with categorical objects, using a frequency-based method to update mode subclusters, a mixture of a categorical and numerical data. That is called K-prototype method. So this is the some variation issues of K-means clustering. Now, before moving hierarchical clustering, I have some more issues on K-means. Then the new question may arise: what is the problem of the K-means? So this may be the interesting question. And the K-means algorithm is sensitive to outliers, okay? Since an object with an extremely large value may substantially distort the distribution of the data. So this is the major, let's say, limitation of K-means. And K-midweights, instead of taking the mean value of the object in a cluster as a reference point, midweights can be used, which is the most centrally located objects in the cluster. So K-means algorithm may have some limitations. Now, talking about next category is hierarchical clustering. So this is the figure you can see in the hierarchical form. Animals may be categorized into vertebrate, invertebrates, okay? Vertebrates may be fish, reptile, amphibian, mammal. Invertebrates may be worm, insect, clustering. So this clustering is basically a special type of unsupervised machine learning algorithm, which is also known as hierarchical cluster analysis. Okay, this is the category of unsupervised learning model. And the objective of hierarchical cluster analysis is to cluster similar unlabeled data points into number of clusters using tree-based structure. You can see in the figure now. So this is the tree-based structure. The data points in the end of a tree forms a set of clusters where each and every cluster is distinct from other clusters, the figure shows. Besides, the data points within a specific cluster are mostly identical to other clusters in the dataset. And basically, in a hierarchical clustering, there are two approaches I just mentioned. First one is agglomerative approach, and second one is divisive approach, which are more common in a hierarchical clustering. And there are different closed sets, pair of clusters, for example, single link, complete link, centroid, average link. I'll show in the figure. So single link has some horizontal relationship with clusters. So this is the single link clustering. So similarity of the most cosine similar single link, okay? Complete link may have multiple link. So this is the single figure of single link example. Next, we have complete link, have vertical as well as horizontal relationship with each cluster, which is more feasible for data compression and analysis. So this is complete link approach. Similarly, we have density-based spatial clustering. It defines clustering based on the density of data points, considering a minimum number of neighbors within a specified radius. And it is effective for data sets with irregular shapes and varying sensitive densities. So density-based spatial clustering is also becoming more popular in different machine learning techniques. So I just told you about agglomerative approach, okay? So this approach is known as bottom-up approach. In this, we start with each object forming a separate group. It keeps on merging the objects or groups that are close to one another. It keeps on doing so until all of the groups are merged into one or until the termination condition holds. So this is the brief information about agglomerative approach. So similarly, I have mentioned about divisive approach. This approach is also known as the top-down approach. So previous one is bottom-up and this one is top-down approach. So in this, we start with all of the objects in the same cluster. In the continuous iteration, a cluster is split up into smaller clusters. It is down until each object in one cluster or the determination conditions holds. This method is rigid. There is once a merging or splitting is done, it can never be undone. So this is a divisive approach, which was developed by Kaufman and Rousseff in 1990. So this is the traditional approach of machine learning. Moving ahead, we have mean shift clustering. So generally, it starts with a random or predefined set of data points as centroids and updates them by shifting towards the local mode of the density estimate. And in this case, the algorithm converges when the centroids no longer move significantly. So mean shift clustering is helpful to identify the data, which are generally dissimilar in nature. Similarly, we have Gaussian mixture models. And this model assumes that the data points are generated from a mixture of Gaussian distributions. And it generally identifies the parameters of these distributions to determine the cluster assignments of the data points. So these are some important issues in clustering, hierarchical clustering. And there are different approaches to improve quality of hierarchical clustering. So hierarchical clustering may have some limitations, but we can improve it. And there are two approaches which are used to improve the quality of hierarchical clustering. And the first approach, perform careful analysis of object linkages at each hierarchical partitioning. And second, integrate hierarchical agglomeration by first using a hierarchical agglomeration algorithm to group objects into microclusters and then performing macro clustering on the microclusters. So two techniques can be used to improve the hierarchical clustering. And there are recent hierarchical clustering methods as well. For example, BERT's model, which was introduced in 1996, ROC model, which was introduced in 1999, Chameleon model 1999. This is called dynamic modeling. A ROC model is clustering categorical data by neighbor and link analysis. And BERT's model is equally important to maintain quality of clustering. So three different approaches are being used nowadays. So this is about Gaussian mixture models. Similarly, we have spectral clustering. So this clustering combines graph theory and linear algebra to perform the clustering. So graph theory and linear algebra has very close relation in spectral clustering. It constructs an affinity matrix representing the pairwise similarities between data points and then applies dimensionality reduction techniques. Similarly, optics, I just told you. So this is density-based clustering algorithm, which creates an ordering of data points based on their density, allowing flexible cluster extraction by defining varying density thresholds. So this is about optics. So what is good clustering? I just mentioned you. We have intraclass and interclass similarity. Interclass has high significance and interclass has low significance. So combination of these two approaches make a good clustering system. So another example of clustering is purity. So in this figure, you can see three different figures here. First, three different clusters having different colors, blue, red, and green. In first cluster, you can see 1 blue, and 5 red. So purity is 1/6, 1 is blue. Altogether 6 components, and the maximum value may be 5, 1, 0. So 5 is red, 1 is blue, and 0 is green. And the average ratio is 5/6. 5 red and 6 are total components. So cluster second, 4/6, and cluster third cluster we have 3/5. So clustering may help to identify the group of the data, sensitivity of the data, and size of the data. Okay, so purity is very helpful in data compression technique as well. So talking more about density-based clustering, this method is based on the notion of density. And the basic idea is to continue growing the given cluster as long as the density in the neighborhood exceeds some thresholds. So that is for each data point within a given cluster. The radius of a given cluster has to contain at least a minimum number of points. So major features of density-based clustering techniques are to discover clusters of arbitrary shape. It can handle noise, okay. It needs density parameters as termination condition. So density-based clustering is equally important nowadays. And in this clustering, we can use different algorithms for data analysis. And it has applications in noise reduction as well. Okay, in many communication devices, we can use density-based scanning system to minimize the noise. So optics, I just mentioned you the basic features. Similarly, we have grid-based method technique of clustering. The advantage of this clustering is that it has fast processing time. Okay, program can be executed faster. It is dependent only on the number of cells in each dimensions in the quantized size. So similarly, we have statistical information grid approach. Which can be used in machine learning. String clustering method, I just mentioned in brief. So string is another approach. Wave clustering by wavelet analysis that was introduced in 1998 by Chatterjee and Chang. Okay, wave cluster. Similarly, we have wavelet transform. And this is a signal processing technique that decomposes a signal into different frequencies of band. And in this situation, data are transferred to preserve relative distance between objects at different levels of resolution. So even wavelet transform using clustering mechanism for data transmission. So similarly, we have model-based method in clustering, which can be used in statistical approach, machine learning approach, and neural network approach. So model-based method may have wide applications in statistical, machine learning, and neural network approaches. Similarly, we have expectation maximization, conceptual clustering approach, which I mentioned you briefly earlier. Neural network approach, I think all of you are familiar with this approach, which is being used long time ago. We have self-organizing feature map for modern machine learning approaches, constraint-based method for cluster analysis, and cluster validation is the final issue. So how we can validate cluster? Cluster validation is the process of evaluating the quality and validity of clustering results. It involves accessing how well the clusters represent the underlying structure or patterns in the data. Cluster validation is essential to ensure that the clustering algorithm has successfully captured meaningful and reliable clusters. So cluster validation is one of the major issues in machine learning. And some important cluster validation methods are internal cluster validation, external cluster validation, relative cluster validation, clustering stability approaches, and so on. I think in this session, we're not able to cover all these issues. I'll provide you some of my important slides so that you can learn by yourself. And the major conclusion of my today's talk is that tens of thousands of machine learning algorithms are being developed nowadays every year. And machine learning algorithms has three important components that I mentioned you about: representation, optimization, and evaluation. And there are various functions of representations. And today I talked about different modern machine learning approaches, detailed information about clustering techniques, their strengths, weaknesses, and applications, and future possibilities on machine learning. So finally, these are some references I used to make the slide. And thank you very much for your kind attention, and your comments, your suggestions and queries are welcome in this session. Thank you very much, Professor Preeti. Up to you now.
So thank you so much, Professor Sharma. And so if you have any question, we can take quick a couple of questions.
Okay, here is one question here. So, sorry, is there any book or online resource where we can get topics that we had explained by yourself and not mentioned in slides? Yes, I will provide you, okay, all these materials to Professor Preeti so that she can share you. Sure, I will share this information to you.
So thank you so much, Professor Sharma, for giving us more about clustering algorithms. And I hope the participants will be able to execute some of the algorithm in the next session. And once again, thank you. Thank you so much. So participants, we will again begin with our next session at 5.
Thank you very much, Professor Preeti.
Thank you for this wonderful talk. Yeah.